Hey, Science 20, welcome back. Okay, we're going to have a couple really quick videos coming up here. So let's just jump right into our next one. This one is how do we calculate speed or velocity when we don't have a graph? So just a few quick reminders. Speed and distance are scalar quantities, so we won't need a direction with them. Uh, Velocity and displacement would be their vector counterparts. Time is only going to be scalar, so we don't have to worry about there being a direction for time. As far as we know, we can only go one direction when it comes to time. The two formulas are pretty much the same. So when we're looking for speed, it's a change in distance over time. And we're looking at velocity, it's a change in position or displacement over time. And both of them are going to have the units of meters per second. So let's just jump right into this quickly here. So we're going to start off with this first practice problem where we see Bobby running 100 meters west, and we need to determine both the speed and the velocity. Now, we need to remember that when it comes to our distance between west and east, west is going to be the negative direction. That's going to be important when we're doing the velocity. And then east will be the positive direction. So again, as always, we're going to identify what variables they've given us. They've given us 100 meters as a distance. Its displacement will be 100 meters west. And then we're going to be looking at the time being 11.2 seconds. And what we're going to be looking for is we're going to be looking for our speed and our velocity. So what I would like you to do is just take a moment and write down the formula for speed and fill in the variables. So pause the video here, see what you can come up with an answer for speed, and then maybe do velocity after, and then unpause, and we'll go from there. Yeah, I want you to pause now. Like seriously, just pause. Okay. All right. So speed is going to be the change in distance over the change in time. It's 100 meters west. We don't have to worry about the direction for this part. 11.2 seconds. And so you take out your calculator and you go 100 and you divide it by 11.2. And what I get is a really big number. Not big, just a lot of decimal places on here. 928571429 meters per second. That's all the digits on my calculator that I'm using. We got 3 sig digs in our distance, and we got 3 sig digs in our, I'm just going to switch colors here. So 3 sig digs here, 3 sig digs here. So our final answer is going to need to be given in 3 significant digits, which for us is going to be 8.93 meters per second. I just want to switch colors here, just so we can do velocity in a different set of colors. Here we're looking for the change in displacement over the change in time. Now the change in displacement is 100 meters west. So we could also call that negative 100 meters from our reference point. So negative 100 meters divided by 11.2 seconds. And as you can see, we're going to get the same answer here. It's just there will be a negative number with it. So we would say negative 8. Oh, let's make that look right here. Negative 8.9. That's only slightly better. 93 meters per second, or 8. Oh, that's better. 8.93 meters per second west. So either of those would be good. Okay, next one. We're giving you the velocity and the amount of time, and we're wanting to find out the displacement of the object. Again, the object is moving 25.0 meters per second west. And so it's traveling at uniform or constant velocity. So it's traveling in the negative direction. That's why we have the negative direction there. Now, a couple things we want to keep in mind. Our time needs to be in seconds. So that's why we're taking the 10 minutes, multiplying it by 60 minutes per, 60 seconds per minute. That's going to give us 600 seconds. Please note, we don't have to worry about the 60 or the 1 when it comes to significant digit calculations. So if you are given a value with 3 sig digs and you're converting it into something else, into a different type of that, or a different unit, in this case, converting minutes into seconds, we're going to keep the same number of sig digs. All right, so our original equation is as so. I should put this in here as the change. We're looking for the change in displacement. So we're going to multiply both sides by delta t so that our displacement is going to equal delta t times our velocity. Time is 600 seconds. Velocity negative 25.0 meters per second. Take a moment, calculate it, pause, and then calculate it, of course. Better have paused. If you didn't pause, oh my goodness, I'm going to be so mad at you. Our answer is going to be negative 15,000 meters. But we need sig digs. We got 3 in our velocity. We got 3 in our time. So that means we're going to need 3 here. Now, I can convert this into 1.5 or negative 1.50 times 10 to the 4 meters. But you know what? 15,000 meters is also going to be 15 kilometers. So we can just calculate it like that. Negative 15.0 kilometers or 15 kilometers west. Okay, last one I'm going to work with you, and then the other examples in your notes you can do at home, no problem. Here we're giving an antelope. It's traveling at a constant velocity of 9.8 meters west. Again, that is going to be a negative sign there. How long will it take for this antelope to travel 2.5 meters or 2.5 meters to the west? So here we're looking for, when it says how long will it take, that is our delta t. So this is what we're going to be looking for. So we're going to rearrange our formula that we had where it was velocity equals delta d over delta t. Now we're just looking for delta t. Plug in the numbers, see what you get. Of course, you're pausing, but plug those numbers in. I'm talking to you. Yeah, you who's looking at the screen, you need to be doing this. Okay, change in displacement. Negative 2.5 meters or 2.5 meters west. The velocity is 9.8 meters per second. But because we're also going west, that's also going to be a negative direction. Now, the nice thing is that since time is a scalar quantity, we don't have to worry about direction. But the directions, the 2 negative signs are going to cancel each other out anyways to give us a positive. We don't need to worry about a sign or anything like that. So anyways, when I put this into the calculator, I get 0.25510204 seconds. How many sig digs? This one, our displacement has 2 sig digs. Our velocity has 2 sig digs. Our answer will have 2 sig digs. There's our answer. All right. Well, that's all I have for you for this video. We'll do a really quick video in our next one. So work on those extra practice problems. When you get those done, we'll talk about it in class. You're going to have to do a little bit of conversion for some of the times in this, but in one of the ones to come. But anyways, work on that. Ask me any questions if you need to. I'll see you in the next video.